AP Calculus, AB, Unit 9, Day 8. This quick little review sheet just to kind of summarize most of the topics that we've gone over. And then there is an assignment that's kind of just a good review assignment. So we can just take a real quick here. Riemann sums, left endpoint. That's what the LE stands for. RE, right endpoint. And this is telling you where to determine the height of each slice, each rectangle. These are all rectangles. Midpoint for the height. Trapezoids are not Riemann sums. This is the area of a trapezoid, average of the bases times the height. Now, you also want to remember over and under estimates. I'm going to just draw little pictures. This is a concave down and increasing. While left endpoint is going to be an under estimate, and that's just because it's increasing. So increasing under. Right endpoint increasing is going to be an over estimate. So left and right endpoint only have to deal with increasing, decreasing. Concavity, trapezoids are pretty easy. It has to do with concave. If it's concave down, it's going to be under. And the midpoint ones are the hardest ones. But if you draw it, you say, well, there's more over than under, so it's going to be over. And that has to be with concave down. It's going to be under. We could draw another one like decreasing, concave up or something. Left endpoint is going to be over. So if it's decreasing, it's over. If it's decreasing, right endpoint is going to be under. Trapezoids are going to be under. If it's concave up, trapezoids are over. And midpoint, concave up. These kind of go with each other, both of these. One is one is the other. So if concave up is over, then concave up is going to be under for midpoints. But you could draw a picture of the midpoint and be like, well, there's a lot more under than over, so the overall effect is me under. Anyways, I find just drawing pictures of those is the best way. Memorizing them, I feel like it's too easy to mess up. Fundamental Theorem of Calculus, Part 1. If you integrate, a nicer way, or maybe more friendly way to me at least, of writing this is if you integrate derivative, you get the original function. That seems pretty straightforward. If you plug limits in, then you plug the top in first and the bottom in second. We use this for a lot of situations where we have information about the derivative and then we have one point and we can use a graphing calculator, or they just give us the value, or they give us a graph of the derivative and we can find the integral of the derivative by using geometry. Absolute values, if they're linear, then you can just use geometry, which means graph it. You get triangles and rectangles and squares and things like that. Otherwise, you have to break up at the intervals, the roots, do a line check, find the zeros, and then break it up. And the negative ones you got to fix by adding a negative. The tabular approach is that little table I showed you guys that we started using when we started doing distance and displacement, but we can use it for absolute values, and it's the same work, but it cuts down a lot of the redundant work. So a lot of things we do multiple times when we break it up, and the table allows you to just do everything once, and it's also kind of a nice way to organize information. Distance and displacement. So important locations, positions, start point, end point, turning points. Displacement is just the change in position from end minus the beginning. And distance is the absolute value is the integral of the absolute value of velocity, which is called speed. And the tables work really well for here. Integrating absolute values, you got to use all the same techniques that you use for any integration of absolute values. Fundamental Theorem of Calculus Part 2 says that derivatives undo integrals, but you still got to plug the limits in after the fact. And the big thing people forget is you got to make sure you take the derivative of what you plugged in, because it's the chain rule, right? It's really just the chain rule. You haven't finished doing derivative if all you've done is the derivative of the outside. Mean value theorem. This is a new mean value theorem for any function, and it's this idea that if you take a curve and the average height is going to be like here, and so the way we do this is if we find the area under this and smooth it out, it's the same area as a rectangle. And that area of the rectangle can be an easy way to find the height of the rectangle, which is what we're looking for. You got to divide by the base, which is going to be b minus a. So what we do is we find the area under the curve, which is the area in the rectangle, and then we divide by the base of the rectangle, and it gives us the height of the rectangle, which is the same as the average height of the function, the average y value of the function. Area between curves, we've been talking about most recently. You can do it with vertical slicing, horizontal slicing. I'm going to ask you to do both. If you're doing vertical, if you have a curve, if you have multiple curves, then you got to find their intersection points usually. And then the vertical slices, you're going to do y top minus y bottom, y top minus y bottom. I'd probably just put them into the same integral. And then you go left to right, x left to x right. Now, if you do the same curve with horizontal slicing, then you're going to do x right minus x left to get the dimension. Remember, these are like thin rectangles. So you're just trying to find the dimensions of these. So it's going to be x right minus x left. I would do them together usually. X right minus x left. That gives that length. This dimension here is going to be the dy. And you go bottom top. You go y bottom to y top to find the area. So this one right here, you could combine into y top minus y bottom dx. And then you're going to go x left to x right. Now, the important thing is that these y coordinates do give you the dimensions of that length, but we got to put them in terms of x. And these is x right and x left, you got to put into dimensions. You got to put in the terms of y. So it's usually a little extra algebra work sometimes. So that's that sheet. And so now we could go ahead and do this review assignment. So you should have checked your answers already. I'll show you the answers right here real quick. So here are the answers. This is assignment 8. It's a bunch of good review problems. We got estimation techniques, integrals of absolute values, area between curves. So pause the video if you need to check these answers real quick. All right. And then these are the next ones. So we got fundamental Thermo Calculus part 2 problems. We got a little bit of different stuff. Fundamental Thermo Calculus part 1, average value, mean value theorem, properties of definite integrals, deciding whether your integral approximations are under or over estimates. Got a little motion stuff, displacement and distance. And then another little properties of definite integrals problem there. So, a bunch of good stuff. So let's try these out. So estimate this integral using these values. We're going to do midpoint with 2 subdivisions of equal length. I'm going to draw a picture. I just find this helpful to organize the information and get all the right values. Distance between these is 32. If we're going to do 2 of them, we got to cut in half, and this can be 16, 16, which puts you at 19. But midpoint means we need to use the middle of these to find the height. So this is 3 to 19, that's 16. So I got to go 8. 11 would be the midpoint there, and 27 would be the midpoint there, right? And those are the values we're going to use from this table. So we got 7 and we got 3. And those are going to be the heights of your rectangles. So 3 to 35 of f of x dx is approximately base 16 times height 7 plus base 16 times height 3. This is work you need to show to get credit on the AP test for response. and credit on my test. So that's going to be 70 plus 42 is 112, 48. So we get 160. Integral to 3 of 3 to 35 of f of x dx. And this is a very appropriate symbol to use in this, because this isn't just off because we rounded or something. Okay, next one, 4 subdivisions. So I'm going to draw my picture. In fact, we could even use what we just did, because essentially those are going to be your 4 subdivisions, 3, 11, 9, 27, 35. But we're going to grab values from all of these. So this is 10, 7, 2, 3, 7. Left endpoint means we're using the left side for each of these, which means we don't use the last one. The bases are all equal. They're all 8, right? And so the integral 3 to 35 of fx dx is approximately base 8 times 10 times height, base times height, 8 times 7, base times height, 8 times 2, base times height, 8 times 3. And so we're going to get 80 plus 56 plus 16 plus 24. So 3 to 35 of f of x dx is approximately, so that's going to be what, 40, 120, 176. Show more work on your paper if you need to. If you don't feel confident, pulling that off. I mean, I get a little scared. Now, this one, we're just going to use all the same values. So why not just quickly take advantage of what we already figured out? That's 4 subdivisions. Trapezoids are going to use both sides. And I'm just drawing this relatively correct. If it's bigger, I try and make it a little bigger. It's not supposed to be perfect. It's just really to help me organize the picture. So trapezoids, you actually just, these which are usually the bases of rectangles, these are the heights of the trapezoids because the trapezoids are sideways. These are all bases. So 3 to 35 of f of x dx is approximately average of the bases, because trapezoids are just the same as rectangles. Base times height. It has 2 bases, so you do average of the bases times the height. Average of the bases, atom divided by 2 times the height. Average of the bases, atom divided by 2 times the height. Average of the bases, 3 plus 7 over 2 times the height, 8. Now, these are all going to become 4s. And so we're going to get 4 times 17 is 68. 4 times 9 is 36. 4 times 5 is 20. 4 times 10 is 40. So that's going to be 90, 104, 164, 164. So the integral 3 to 35 of f of x dx is approximately 164. This is the kind of work I hope to see. 1, to help you get the right answers, and then 2, if you get them wrong, to help give you partial credit. Okay, absolute values. Now, these we could do a couple different ways. I mean, if it's linear, we have 3 different ways of doing it. We could graph it. I think I'm going to let you choose 1, 2, 6. So if I'm going to graph it, 1, 2, 3, 4, 5, 6. Just do a quick graph. 1, 2, 3, 4. Okay, so y-intercept's -6, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So that's the initial line, and the absolute value flips the negative part up. So it's going to be up here. So this is absolute value graph, which makes sense. It's like a V-looking graph. So if we're going to do this, we could split it into a big triangle and a small triangle. So we do 1/2 base times height plus 1/2 base times height. So that's going to be 1/2. The base of the first triangle is 3. The height is 6. The base of the second triangle is 1. The height is 2. So that's going to be 9 plus 1 is 10. These are exact answers. So that's one way to do it. The other way is you could find the zeros to figure out where to split this up without having graphed it yet. Say, okay, we got to break it up to 3. You can do a line check, test a point, x equals 4. That's going to be positive, negative. You can even look at the graph we just did. There's the negative part down here, so we got to fix it. So we could do a table using this information. We got to integrate what was inside the absolute value without absolute value. So this is going to be 2x squared over 2 minus 6x plus c. Don't need that. We plug in 0, 3, and 4. Plug 0 in here and you get 0. Plug 3 in here, you get 9 minus 18 is negative 9. Plug 4 in, you get 16 minus 24 is negative 10. The distance here is 9. The distance here is 1. You add these up and you get 10. Same answer. The other way of doing it, kind of the most straightforward, but also most tedious, is to split this up and say, all right, we're going to do 0 to 3, drop the absolute values, and then we're going to do 3 to 4, drop the absolute values, and then the negative part we got to fix by adding extra negative, and then we're going to integrate these. 2x squared over 2 minus 6x, 0 to 3, plus same antiderivative, x squared minus 6x, 3 to 4, and then we're going to start plugging all these values in. So you get negative 9 minus 18 minus 0 minus 0 plus 16 minus 24 minus 9 minus 18. So that's going to be positive 9 for this first chunk, plus this is going to be negative 8 minus negative 9. So that's going to be positive 1. And you get 10. Same answer. So you got a few different ways of doing that. I mean, geometry one's pretty kind of nice, but that only works for specific problems. The other two methods can be used on any problem. So this next one, we can't do geometry. It's not linear. It's quadratic. So we're not even bothered trying to graph it. So we for sure got to find the zeros. And it has 2. And then we can do a line check and test the value. And it's going to be positive, negative, positive. So this tells you, you can do the table. Table's kind of quicker. X, integral of x squared minus 2x dx equals x cubed over 3 minus 2x squared over 2 plus c. I'm going to plug in 0, 2, and 6. You plug 0 in, you get 0. You plug 2 in, you get 8 thirds minus 4, which least common denominator would give you negative 4 thirds. Plug 6 in, 72 minus 36 is 36. So the distance here is positive 4 thirds. The distance here is 37 and 1/3. So if you add those together, you're going to get, that's 1 1/3, 38 and 2/3, or whatever that is, 90 plus 24 is 114, 116 thirds. So that's sort of that kind of shortcut, kind of not do all the work. Otherwise, you can, you can kind of do it the other way, where we say, okay, well, we're going to go 0 to 2, parentheses x squared minus 2x dx, and then we're going to go 2 to 6, x squared minus 2x dx, and the negative part we got to fix. Okay, so then we're going to get negative x cubed over 3 minus 2x squared over 2, 0 to 2, plus Same antiderivative x cubed over 3 minus x squared, 2 to 6. We've got to plug all these values in. So we plug 2 in, you get 8/3 minus 4 minus 0 plus 72 minus 36 minus 8/3 minus 4. And then you just got to keep going with that work. Make sure you get it right. I'll let you finish that up, that last arithmetic. You'll get the same answer though. Okay, so next one, we want to figure out where this equals 0. So we set it equal to 0 and we solve for trig and we get alpha equals pi over 6, quadrants 1 and quadrants 2. You guys should be great at trig hopefully by now. We do a line check. We're only concerned with 0 to pi over 3. So, we could say x equals pi over 6 plus 2 pi k. X equals 5 pi over 6 plus 2 pi k. We just want the ones that are between 0 and pi over 3, so that's just going to be pi over 6. And then we'll test a point. I'm going to use 0 because it's not a root. That's going to be negative and then positive. So we could do the table approach. I'm going to integrate 2 sine x minus 1 dx. That's going to give you negative 2 cosine x minus x plus c. Don't need to really worry about the c. Plug limits in 0, pi over 6, pi over 3. Plug 0 in here, you get negative 2, right? Because cosine of 0 is 1. Plug pi over 6 in, you get negative 2. Cosine pi over 6 is root 3 over 2, so you can get negative root 3 minus pi over 6. And pi over 3, cosine pi over 3 is 1/2, so it's going to be negative 1 minus pi over 3. Now, when you go to find the distances, this is one that I think is harder because you could try and estimate all these decimals, and that would help you figure out which one to subtract from the other to make sure it comes out positive. It's easy usually if there's just numbers to kind of do in your head without even thinking about it. This is where the line check comes in. This first chunk is a negative part of the graph, so you want to go backwards. You want to subtract. You want to go earlier minus the later one. Usually we do later minus the earlier, right? Top limit minus bottom limit, but I'm going to do bottom limit minus top limit. It's going to be plus root 3 plus pi over 6. If you put this in your calculator, it should come out positive if you've done it right, okay? And then we're going to do this next part's positive, so we just do the normal thing. Negative root 3 minus pi over 6 plus 1 plus pi over 3. We could clean that up a little bit. This is plus pi over 6. So if we add these together, that should give you your answer. So pi over 3's cancel. You get 2 pi over 6 minus 1. You get pi over 3 minus 1 is your answer. But I think I made a mistake somewhere. So let's see. Let me double check my work. It's different than the answer I have in my solutions. So that looks good. This one should be that minus that. Okay, I did it backwards. I think I was saying the right thing. Is negative 1 minus pi over 3 minus this. So plus root 3 plus pi over 6. And so then this is going to be positive root 3. I haven't even done it. It's going to be positive root 3. I think that's what this is right here. Okay. It's going to be positive root 3 minus 1 minus pi over 6. So now if we combine these together, we have 2 root 3 minus 3, and then the pi over 6 and the negative pi over 6 cancel. So that should be your answer. It's easy to make little mistakes. You gotta be careful. Otherwise, you could take the approach of, okay, well, we're gonna split it up. We're gonna just write separate integrals. First one's going to be 0 to pi over 6. It's going to be the negative one. So we've got to fix it with a negative. And then pi over 6 to pi over 3. And then, so it's negative. It's going to be negative 2 cosine x minus x plus negative 2 cosine x minus x pi over 6 to pi over 3. And then you got to plug these values in. Now, this one, I think it's harder to like subtract the wrong way, but it's just a lot more little calculations. So it's trade-off. So cosine of pi over 6 is going to be root 3 over 2, so it's going to be negative root 3 minus pi over 6 minus cosine of 0 is 1, so it's going to be negative 2 minus 0. And the next one is going to be negative 1, because cosine of pi over 3 is 1/2, minus pi over 3, minus pi over 6 is going to be root 3 over 2, so it's going to be negative root 3 minus pi over 6. And then you just got to keep going. You got to distribute these negatives correctly. So this first one's going to be root 3 plus pi over 6 minus 2. Now, if you look up here, that's the same thing we got in the table for that first term, right? This next one should be the same as the next one right here. So this is going to be plus negative 1 minus root, or we got to distribute this, minus pi over 6, because that's 2 pi over 6, negative 2 pi over 6, positive pi over 6, it would be negative 1 pi over 6, plus root 3. And the root 3 and the root 3 give you 2 root 3. The pi over 6 and negative pi over 6 cancel. And the negative 2 and the negative 1 give you minus 3. And you get the same answer that we got that way. Just whichever way you do it, be careful. Okay. Next, we got area, set the intervals in dx and also dy, and then calculate the area. So you should be able to do these by hand and also calculator, because you will have a calculator section of the test that you can just set them up and then use a calculator, but there's also going to be ones you got to do by hand. So it's probably good to do it both ways and see if all the answers come out the same. I do dx, dy, do them both by hand, do them both with my calculator, make sure they all give the same answer. So dx is going to be vertical slices like normal. And to get the dimensions of that thin rectangle is going to be y top minus y bottom. The other dimension is going to be dx, right? So if we go to find, now we also got to find the intersections. So we're going to set these equal to each other. I would divide the 4 out of both sides before making it more complicated. Square both sides. Move everything one side equals 0. Factor it. Okay. So those are the x values. So this is 0. If you plug x equals 0 in either of these equations, you get the y value 0. You plug 1 in to either of these, you get 4. So those are going to give you the limits. So we need to do y top minus y bottom dx. And so the limits are going to be left to right, x equals 0 to x equals 1. Y top in terms of x is it's just 4 squared of x. Y bottom is 4x. and then you can just try and integrate it by hand. Let's see what happens. Let's see. That's going to be 1/2 power, so it's going to be 4x to 3/2 times 2/3. That's 4x squared over 2, 0 to 1. So it's going to be 8/3 minus 2. Plug 0 in, you get 0 minus 0. Least common denominator is going to be 3. So 8/3 minus 6/3 is 2/3. So that's the answer. Let's try it with horizontal slicing. Draw a slice. Just draw one slice. X right minus x left. These aren't formulas to memorize. These are things to look at the picture and make sense of. If you don't understand this, you're not going to do well. So the dimensions of this thin sort of sideways rectangle, one dimension is x right minus x left, the other dimension is dy, that small little thickness of it in the y direction. So we're going to go in the y direction, bottom y is 0, top y is 4. We need to write x right in the terms of y, and that came from right here. X right is y over 4. And then x left comes from this guy. That's going to be y squared over 16. Y squared over 16. On the test, I'm going to make you do it one way or the other. This is just your chance to practice both and make sure you're really good at both of them, no matter what. So the antiderivative is going to be y squared over 8, because it's already over 4, and you get another 2, minus y cubed over 48, 0 to 4. Plug 4 in, you get 16 over 8 is 2, minus 64 over 48. Plug 0 in, you get 0 minus 0. So 16 goes this 4 times, 60 goes this 3 times. So this is least common denominator would be 3. So 6/3 minus 4/3 is, surprise, 2/3. Now you should also be able to, after setting these up, feel confident about putting them into your calculator, and they should give you the same answers. So you guys should be, this first one, I'll just do it from the home screen. Math 9, 4 square root x minus 4x, comma 0, comma 1. Boom. So if you can use a calculator, this is the way to go. Super fast to enter. Sometimes it takes a little while to calculate, but pretty much the same thing, right? 3 decimal accuracy. And then the next one, math 9. Even though there's y's, I'm going to put x's, because that's the only variable we can enter in our calculator. So it's going to be x over 4 minus x squared divided by 16, comma x, comma 0, comma 4. It should give us the same answer. And it does. We're good. Okay, next one. Let's see if we can figure this out. So R is this region right here. So if we do vertical slices, one disadvantage this time is that y top minus y bottom changes. So you're going to have to set up two different integrals at this intersection. You got to find all the intersections. So this intersection is going to be setting these two equal to each other. 6 equals negative x plus 6, x equals 0, which looks like it does. If you plug 0 into either one, you should get 6. So we got that one. This one, you'd set these two equal to each other. X squared equals 6. Square root of both sides, plus or minus. So you get plus or minus root 6. This is the positive root of 6. If you plug it into either of these equations, you should get 6. And this intersection is by setting these two equal to each other, which is the x squared equal to the negative x plus 6. So I'm going to move everything to one side. Like we do anytime we solve a polynomial, factor it. And we get two roots from quadratics like usual, but this one is the positive one, obviously. This is positive x. It gives you this other one because these graphs would keep going and intersect up here. That'd be the negative 3 x coordinate. So 2, if you plug 2 into either one of these, you get 4, right? So we got all our things. We're going to have to chop this up, do this area, and do this area separately. So with vertical slicing, it's going to be y top minus y bottom, right? Dx. First one is going to be 0 to 2, x left to x right. Y top is the line 6. Y bottom in terms of x is negative x plus 6. Make sure you put in parentheses. Plus 2 to root 6. And it's going to be, y top is going to be 6 again. Y bottom is going to be the square x squared dx. So that's the setup for vertical slices. And then I would simplify this. This is going to be x. This is just going to end up being x, right? Because the 6 and the minus 6 cancel each other out. So it's kind of nice. X squared over 2, 0 to 2. This one's going to be 6x minus x cubed over 3, 2 to root 6. So you plug that in, you get 2 minus 0. Plug root 6 in, you get 6 root 6 minus, this is going to be 6 root 6 over 3 minus 12 minus 8 thirds. So that's all that second one. So just got to try and clean this up. So that's going to be 2. So you give these least common denominator if you want. I should give this guy the same thing. So we got 36 minus 8 is 24 thirds, negative 24 thirds, positive 6, so negative 18 thirds, plus 6 root 6 minus 2 root 6 is going to be negative 6 plus 4 root 6. Now you can check on your calculator, that better come out to a positive answer. I'm getting a different answer than I got when I did it, so I must have made a little mistake somewhere. So 36 minus 8. Oh, 36 minus 8 should be negative 28, negative 22. Yeah, that's it, negative 22. Negative 22 thirds. Negative 22 thirds. Okay, so that's vertical slicing. Horizontal slicing, I think, is going to be a little easier because there's only one slice the whole time. So horizontal slicing, you're going to do x right minus x left, dy. And in this case, we're going to integrate from bottom y to top y. That's going to be 4 to 6. X right is this right here, which you get by taking the square root of both sides, plus or minus. It's the positive one. It's the positive square root of y. X left over here is going to be this line, solve for x, which would be x equals 6 minus y. Make sure you put in parentheses. So that's your setup. Much less complicated than up there. And then we can integrate it. It's going to be y 3 halves divided by 3 halves minus 6y plus y squared over 2, 4 to 6. So we plug it in here. We get a 6 to the 3 halves. So that's the square root of 6 cubed minus 36 plus 36 over 2 is 18 minus plug 4 in. Square root of 4 is 2, cubed is 8, 16 thirds minus 24 plus 16 over 2 is 8. Now this, we could take a 6 out and it'd be 6 square root of 6, right? And so then that would give you 2. That would be 4 root 6 minus 18 and minus 16 thirds. And that's going to be minus 16. That's going to be plus 16, right? Minus 16. Okay. These guys are going to end up giving negative 2, which I give least common denominator would be 3. And so we're going to get 4 root 6. And then minus 22 thirds. Same answer. Now, if you plug these in your calculator, I would figure out what the decimal is for these, and then plug these both in your calculator and see if you should get the same decimal. It should come out to 2.464 or 2.465. So if you plug them in your calculator, you should get those same two answers. Now for a nice break and a couple of super easy problems. You guys should love these. Fundamental Thermo Calculus Part 2. Right? And it says derivatives of undue integrals. But then you got to plug limits in. So it's going to be sine 2 minus sine x squared. Now I'm leaving extra room because the other part is we got to follow it up with a chain rule. and multiply by the derivative of what got plugged in, only what got plugged in. And if you just plug in a number, that term is going to go away because it's constant. So our answer is going to be negative 2x sine of x squared. Done. Fast, easy, hopefully get them right. Next one, derivatives undo integrals. That's the basic idea. And then we plug limits in. So this is going to be cosine of, and I'm just careful to put these in parentheses first. There's no rush. Otherwise, you're going to mess it up. Parentheses e to the 2x squared. And then you multiply by the derivative of only what you plugged in, not x to the 6, x cubed. So it's going to be 3x squared. E to the 2x is going to be 2e to the 2x. It has its own little chain rule in it. And then you write your final answer, simplify 3x squared cosine of x to the 6 equals of exponents minus 2e to the 2x cosine of e to the 4x. Done. Easy, quick, correct. All right. This one says if f is decreasing and concave down, then which integral approximations produces underestimates? Well, I would just draw a sketch, decreasing and concave down. Okay, just draw one slice. Left end is going to be over. Right end is going to be under. So we're looking for the, and then midpoint isn't listed on here. I'm going to add to the list. So right isn't, trapezoid is clearly under, which means midpoint, they kind of go in sort of pairs. Midpoint is going to be over. It has more over than under. So midpoint is over. So the under approximates are right end and trapezoid. I don't try and memorize those. I really don't. I don't think it's going to pay off. I think I'll get problems wrong. I'll be more frustrated. It'll take me longer. I'm just going to draw a quick sketch. Use some common sense if you understand what we're even trying to do here. Okay, properties of definite integrals. We've done a lot of these. So if you want negative 1 to 6, see these? I kind of want to add these together, but one's got to be on the top, one's going to be at the bottom. So I got to flip one of them. So what I could do is, because this has a negative, if I flip them, that'll add an extra negative. And it'll be 2 to negative 1 of f of x dx. And so then it'll equal negative 5. And so then if I add these together, the top matches the bottom, that'll give me 6 to negative 1 of f of x dx. And it's going to be negative 5 plus negative 2 is negative 7. That's not exactly what I'm looking for. I'm looking for the same thing, but upside down. Well, that's easy fix. It's going to be positive 7. I'll just flip it upside down. I could have flipped the other one upside down first, and then it would have been more correct. But I don't know. That just seemed to be the way to do it. Here's a graph of f prime. Here's a initial condition. And here we want to find this. This is total good example for fundamental theorem of calculus part 1. Fundamental theorem of calculus part 1 says, hey, if you integrate the derivative of a function, you get the original function. So if you want to, and you know 5, put them smallest and biggest, and then you plug limits in. And so we're trying to find this. So if I were to solve for this, f of 2, I'd add it over here, subtract this over here, I'd get f2 equals f5 minus the integral of 2 to 5 of f prime of x dx. Now f of 5, they gave me a 7. This I'm going to get from the picture. I'm going to go from 2 to 5, which means find this area. Now I could do that with a single trapezoid, right? Or you could do a rectangle and triangle. It's up to you. If I did a single trapezoid, the bases are 3 and 1, and the height is 4. So the average of the bases 1 plus 3 over 2 times the height is 4. That's going to be 8. And so the answer is going to end up being negative 1. Okay? So that's one way. Average value, this is mean value theorem of a function. It's not a derivative. So f average, I don't memorize this formula. I think, okay, I envision this graph. I say, okay, let's take the graph, let's level it out and get the area of that rectangle, which would be the same area under the original graph. So the area under the graph is going to be the area of the rectangle, leveled out, divide by the base of the rectangle, gives you the height of the rectangle, which is what we're looking for. So that's the setup. I guarantee if you don't think that through every time, you're going to get it wrong. I tried to memorize it my first year teaching this class, and gosh, I was doing terrible with it. I was mixing it up with fundamental Thermo Calculus. I was just trying to memorize too much stuff, which was hard, and I was getting them wrong. The antiderivative sign is negative cosine. So the rest is just definite integral work. So negative cosine of pi minus negative cosine of 0, which is not 0. Cosine of pi is negative 1. Cosine of 0 is 1. Plus, 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 plus. So this is going to be 2 over pi. Now, the other thing that you might get asked on these is to find the c value where the function equals the exact value of the average. It should happen at least once. So if they didn't ask it here, but if they did, you take your original function and you'd set it equal to the average value. And then you'd solve. Now, fortunately here, it's going to be ugly. It's going to be inverse sine of 2 over pi. In fact, this is actually alpha. And it would be quadrant 1 and quadrant 2 because it's positive. We're only looking for values between 0 and pi, which is quadrant 1 and quadrant 2. Quadrant 1 answer would be x equals just alpha. And that's a C. That's what we call C. Quadrant 2 answer, well, how do you find the angle if you know alpha? You do pi minus alpha. So ugly answers, but still doable without a calculator. Those are the exact answers. So you could be asked about that. Okay, motion. Rectilinear motion, one-dimensional motion. Johnny's acceleration is given by that. We have initial velocity, initial position. We want to find displacement and distance. Now, displacement is equal to the integral of velocity from 0 to 4, which ends up being the position at 4 minus the position at 0. You can do that. Distance is the integral of the absolute value of velocity from 0 to 4. I'm going to make a my preferred method is to make a table to do all this stuff. And so this would be 0 to 4, absolute value of 12t minus 18 dt. I'm going to factor out a 6, 2t minus 3, t equals 3 halves. So that's a turning point where velocity equals 0. So my table would look like this. I can use the table for both parts A and B. Time integral of 12t minus 18 gives you 12t squared over 2 minus 18t plus c. Now, we could find the c value, but it's just not necessary for this problem because every term is going to have the c value. So it's going to be 0, 3 halves, 4. If I plug 0 in here, I get 0. If I plug 3 halves in here, I get 6 times 9 fourths minus 18 times 3 halves is going to be 27 halves minus 54 halves is going to be negative 27 halves. And I plug 4 in, and I get 6 times 16 is 96 minus 72 is 24, or 48 halves. And then for displacement, what I do is I just take the final spot minus the initial spot. And so that's just going to be 24. That's displacement. And then distance, I'm going to find the distance between these. And so this is positive 27 halves. And then this is 60, 75 halves. And so the distance is going to be 90, 102 halves, which is 51. Except that it looks like I made a mistake somewhere. Where did I make my mistake? Oh, shoot. This is acceleration, so we have to find the velocity equation. So this is all wrong. I got a little too carried away. Velocity is going to be the integral of v prime dt, which is the integral of acceleration, which is the integral of 12t minus 18 So we're going to get 12t squared over 2 minus 18t plus c. And we do need to find the c value. We're going to use initial conditioning, plug 0 in. And it should come out to 12. So the velocity is 6t squared minus 18t plus 12. This is what we should put in right here. 6t squared minus 18t plus 12. So now finding the 0 of that, you'd factor the 6 out, t squared minus 3t plus 2. And that would be t minus 1, t minus 2. And you get t equals 1 and t equals 2. These are what we should have put in our table, 1 and 2. So this work just doesn't make sense. If you plug 1 in, I mean, the work is a lot easier this time. We're supposed to be integrating 6t squared minus 18t plus 12. So that's going to give us 6t cubed over 3 minus 18t squared over 2 plus 12t plus c. It's going to be 9. That's going to be a 2. So if you plug 0 in here, you're going to get 0 still. If you plug 4 in, you're going to get 2 times 64 is 128 minus 9 times 16 is 90. So 144 plus 12 times 4 is 48. So that's going to be negative 96. It's going to be positive 32. If you plug 1 in, it's going to be 2 minus 9 is negative 7, plus 12 is 5. And if you plug 2 in, you're going to get 2 times 8 is 16, minus 9 times 4 is 36, plus 2 times 12 is 24. So that's going to be 4. So the displacement is now going to be the ending value, 32, minus the first one, 0. So that should be 32. The distance between these is 5. Between 5 and 4 is 1. Between 4 and 32 is 28. So if you add those up, you get 34. So unfortunately, I messed that one up at the beginning. But I fixed it. Now it's a mess. Look at my worked out solutions. Okay, last one. Definite properties of definite intervals. So if we look at these, we say, oh, we could add these up. Look, boom, boom, boom. That would give us negative 1 to 2 of f of x dx, which would give you 5 plus 2 is 7. I'm just jumping on that because I noticed it. Now, when I rewrite this, I'm going to say negative 1 to 2 gx dx. I'm going to split this up. That's your best bet. You have to integrate the 4 separately. This I just found was 7. This one you could find the antiderivative for x and plug in the limits. 8 minus negative 4 is 12. So you get 7 plus 12 is 19. Or you could look at this guy and say, oh, that's just a flat line 4. I'm trying to find the area under from negative 1 to 2. So it's a rectangle. Base times height, 3 times 4 is 12. All right, there you go. Some good practice. Start getting ready for that next test.